Okay, so I went through that, invested time going over everything again because now we just have to decide which test to use. So if it says just convert, or diverge, then you're going to need test for divergence or p-test. If it says converge or diverge and find the sum, then you know it's geometric or telescoping. All right, so this one does say find the sum. So I'm going to encourage you to circle it, remind yourself, oh, right, okay, so it's got to be either geometric or telescoping. Telescoping is a fraction that you'll do partial fractions on. That is not, this is geometric, right? So if it's a geometric sum, I'm trying to find the common ratio. So I can't have a subtraction. So that means I'm going to split it up into two separate sums. So I'll have 1 over e to the n plus 1, subtract negative 2 to the n over e to the n plus 1. Okay, so for each of them separately, I'm going to figure out what the a and the r are equal to. So let's go right out first few terms here. So plugging in n equal 1, I'll get 1 over e squared, n equal 2, e cubed, n equal 3, e to the 4th. Okay, so I see that a is 1 over e squared and r is 1 over e. So this converges. So the a over 1 minus r would be the answer. Okay, this one here. If I plug in n equal 1, I get negative 2 over e squared. Plug in n equal 2, I get negative 2 squared over e cubed. Plug in n equal 3, I get negative 2 cubed over e to the 4th. So I can see what a is equal to. So what's r? So by looking between here and here, looks like r will be negative 2 over e. We know that e is 2.7. This is 2 over 2.7, so this is smaller than 1, so this converges. So the sum, let's put the subtraction sign between the two, the sum will be a over 1 minus the negative r. That's the sum. All right, looking at this one here, I do see addition in the top, so let's break it up into two separate fractions so I can see what's going on. So even if I keep them together at first, and then I'll have 1 over 3n squared for the first one, and then plus 2 over 3n to the 4th for the second one. All right, this looks like p-test, and 1/3, right? If I wanted to, I could take the numbers on the outside. Not necessary, but sometimes it's helpful for you to, if you're having a hard time seeing what it is, right? This one I could pull the 2/3 out in the front. So 1 over n to the 4th. They both converge by p-test. Okay. This one says if convergent, so converge or diverge is kind of the main question, and then this one adds on, if convergent, find the sum. Okay, so it's got to be geometric or telescoping. I can tell this is going to be geometric. I see addition in the numerator, so I'm going to separate it to two separate sums. Okay, so let's go and find out what the a and the r are equal to. Whoops, n equal 2, n equal 3. So plugging in n equal 1, I get 3 cubed. Plug in n equal 2, 3 to the 4th, n equal 3, 3 to the 5th. So here's a. This is ar. So r must be 1/3. So this does converge. So this one will have a sum of 1 over 27 over 1 minus 1/3. Let's look at this one here. So if I plug in n equal 1, I get 4 over 3 cubed. So that's plugging in n equal 1, so that's what a is equal to. Plugging in n equal 2, I'll get 4 squared over 3 to the 4th. So that's AR. Then AR squared is when I plug in n equals 3. So I'll get 4 cubed and 3 to the 5th. So if this is A and this is AR, R must be 4 over 3, right? 4 over 3. Oh no, this R is absolute value of R is bigger than 1, so this sum diverges. So perhaps I have a sum from this one, but I'm going to be adding on divergent, so the whole thing diverges. There's no sum. This one here, this is not geometric, because this, if I was to rewrite it as the exponent that it is, I have 1 over n power. You're actually probably getting bored of me doing this same problem over and over again. You recognize it, you say, right, that's not p-test. The only thing that can be used on this is my test for divergence. So I get 2 over 3 to the 1 over n. When I put in infinity up here, 1 over infinity is 0. 3 to the 0 is 1. So I get 2. That does not equal 0. So therefore, it diverges by T for D. Converge or diverge. If converge, find the sum. Okay. So I'm looking at that thinking, yep, that is definitely a telescoping problem. So let me dig onto it in the next video.